The last thing we're going to talk about on functions is in 1.6, and we're going to talk about the inverse of functions. Basically, when you are doing the inverse, this is the notation. Here's your original function. This is the inverse of f. It is denoted by a -1 exponent. And when you find the inverse of a function, your domain and range flip. The domain of f becomes the range of the inverse of f, and the range of f becomes the domain of the inverse of f. When I'm finding the inverse, or when I'm asked to verify the inverse, I want to do two compositions. Okay, I want to put the inverse function inside the original function, and then I want to put the original function inside the inverse function. Both of those should come out to be x, and that's how you know how you have verified algebraically that both of these are inverses of each other. Find the inverse of function f of x equals 4x informally and verify that they are inverses. Okay, up here our function is f times the number x. So we're taking our input, which would be our x, multiplying it by 4. You're always looking at what's being done to x. It's being multiplied by 4. If I'm finding the opposite informally, f to the -1 of x equals, the opposite of multiplying x by 4 would be dividing x by 4. So I would say this is the inverse of f of x. If I want to verify, okay, I'm going to take f of x and put inside the inverse. So I'm taking 4x, I'm going to replace x with x over 4. That's going to come out to be x. And I also want to do it the other way. I want to start with the inverse, put in the original, and see what I get. So if I start with the inverse, here's my inverse, replace x. Now I've got 4x over 4 equals x. Verified. Okay, pause this and see if you can think about what the inverse is going to be informally and see if you can write out the verification for that. F inverse of x, since I'm doing x subtract 6, I'm subtracting 6 from x. I'm going to do the opposite, which would be x plus 6. Verifying, I'm going to do f of f inverse of x. So start with my original, replace x with my inverse, comes out to be x. Other way, start with the inverse, put in the original. Okay, start with my inverse, replace x with my original, and this also comes out to be x. Verified. Does a function have an inverse is a question you're going to come across. A function f has an inverse if and only if the original function is 1-to-1. A 1-to-1 function passes the horizontal line test. Basically, this is saying that no two elements in the domain of f correspond to the same element in the range. Kind of like the backwards. On a function we said x cannot repeat, but on here it would be y cannot repeat. But it's easy to do from a graph doing the horizontal line test. Okay, algebraically, if I want to find the inverse, we're doing the way you probably learned in Algebra 2. You're going to switch x and y, solve for y. Okay, so if I take my function, you know that that's y. So we're going to say x equals 5 minus 3y divided by 2. Multiply my 2 over 2x equals 5 minus 3y. Subtract my 5 over 2x minus 5 equals negative 3y. And divide by negative 3. Y equals 2x minus 5 divided by negative 3. You could distribute that negative to the top so that your denominator is positive and make this 5 minus 2x. Just change the signs on top. It doesn't matter to me which way you write it, they both mean the same thing. Okay, to verify that two functions are inverses of each other graphically, we've done it algebraically, and we'll do it again, but this is graphically. What I've done is I put my original in, and I've put my inverse in, and now I'm going to look at what the graph looks like. So my blue line coming in is my original. My red line is what I think that I found my inverse to be. And then what you want to check is that these lines are reflecting over the line y equals x, which is your diagonal line. Easy way to see this is if I go down, add a third equation, just x, and graph it as well. And these lines do indeed flip over the not the x-axis, the line y equals x, therefore graphically they're inverses of each other. Okay, algebraically, I'm going to take those two equations and substitute them into each other. Oh, make that smaller. Okay, I'm going to take my original equation and put in my inverse. Okay, my original equation was 5 minus 3x over 2. I'm replacing x. 5 minus 3 times my inverse, 5 minus 2x over 3, divided by 2. And to simplify, my 3's, top and bottom, are going to cancel out. Distribute the minus that comes after the 5 is going to become 5 minus 5 plus 2x all over 2. 5 minus 5 cancels, 2x over 2 equals x. Now go the other way. F inverse of f of x, start with my inverse, 5 minus 2x over 3, replace x, 5 minus 2 times 5 minus 3x over 2 over 3. Simplifying, my 2's are going to cancel, distribute the minus. It's going to be 5 minus 5 plus 3x over 3. 5 minus 5 goes away. 3x over 3 simplifies to x. Okay, find the inverse and verify. First, I'm going to switch x and y. X equals y cubed minus 4. Add my 4. X plus 4 equals y cubed. How do I get rid of a cube? I'm going to cube root x plus 4. There's y. There is my inverse function. Verifying f of f inverse x. I'm going to put it in one step. So instead of x cubed, I'm going to be putting in cube root of x plus 4 cubed minus 4. Again, this is putting the inverse into the original. A cube and a cube root are going to cancel each other out just like a square and a square root do. So now I have x plus 4 minus 4, which equals x. Go the other way, f inverse of the original function. Start with my inverse, replace x with my original. Okay, my minus 4 and my plus 4 are going to cancel each other out. So I'm going to have just the cube root of x cubed. And just like before, a cube root cancels out a cube, which leaves me with x. Try this one on your own before you watch the rest of this video. Okay, if I switch my x and y, I'm going to have x equals square root 2y minus 3. I have to work my way outside in, so to get rid of the square, or the square root, I'm going to have to square the x. Then I'm going to have to add the 3. And then I'm going to have to divide by 2. So there is my inverse. Verifying original, put the inverse inside. It's going to be square root of 2 times x cubed plus 3 over 2 minus 3, and that is all under that square root. The 2 and the 2 cancel. Square root of x cubed plus 3 minus 3. Oh, that should have been a square all along. Square, 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 square. Okay, my 3's go away. Square root of x squared equals x. Going the other way, starting with my inverse, putting my original in. Start with my inverse, I start with x squared, so in here, put my original, square it, plus 3 all over 2. Square and the square root cancel. 2x minus 3 plus 3 all over 2. These cancel. 2 and the 2 go away. Only left with x.